Good afternoon, everyone. I'm Cassie with EMA, and I'd like to welcome you to today's webinar. I also want to thank our sponsor, Facility Grid, for supporting this session. Just a few items to cover before we get started. Our presenters will hold questions today until the end of the presentation, but we encourage you to submit your questions at any time using the Q&A button on Zoom. If you happen to be experiencing any technical problems during the webinar, please use the chat function to inform the panelists so that our producer, Will, can assist you. This presentation is being recorded and it will be available for viewing in 1 week. In terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you're a certified EMP, your CEUs for attending this webinar will be automatically uploaded to your respective portal after the webinar. Our webinar today is From Roadmap to Reality, Executing Data Center Commissioning with Operational Readiness in Mind. I'd like to welcome our speakers for today, Alex Kozinets and James Magee. Alex Kozinets is the Chief Product Officer for Facility Grid, as well as a former mechanical engineer and commissioning manager and an active member of ASHRAE SSPC 300 Commissioning Committee. Alex acts as a customer advocate in the process of establishing product strategy, bringing over 25 years of experience in master planning, project management, mechanical engineering design, construction administration, startup, and commissioning across various projects in several industries. James Magee, CXA EMP Lead AP, is the Executive Director of MACx Consulting, LLC in Gilbertsville, Kentucky, a consultancy founded in 2024 that is dedicated to developing and executing practical building systems commissioning processes. After earning a degree in mechanical engineering from the University of Kentucky, James had 17 years of HVAC test and balance experience as an AABC TBE, prior to 24 years of commissioning experience as an ACG certified CXA. He also founded Kentucky's first independent third-party building systems commissioning company, Facility Commissioning Group, serving as CEO and senior project manager for a 423 project career portfolio and transitioning to principal in 2020. FCG successfully commissioned over 800 projects during Jim's tenure. James is a founder and past president of ACG, a charter certified commissioning authority, CXA, and former chair of the ACG Building Systems Commissioning Guideline Committee. Jim is treasurer of the Southeast Region Building Commissioning Association and member number 20 of the Building Commissioning Association. Jim is a voting member of ASHRAE SSPC 300 and chairs GPC 1.6P Commissioning for Data Centers Subcommittee. He is certified by USGBC as a lead accredited professional and is also a member of ASTM, NFPA, ASME, and the Kentucky Society of Healthcare Engineers. Without further ado, I will hand it over to Alex and Jim to kick us off.
Good afternoon, everybody, and welcome to our presentation today. This afternoon, we appreciate your time on a busy Thursday. Alex and I have a history together where we've worked through ASHRAE and all through BCA and ACG. And Alex, it's been a pleasure working with you. I was surprised in Las Vegas when we met on the guideline committee. You came prepared with a definition that we'll talk about today. I thought that was very good. So it's good working with you again.
Same here, Jim, and looking forward to this webinar. Let's
All
start.
right, let's get moving forward then. The presentation, I'll just line, this is really about means and methods for data center commissioning framed around the concept of operational readiness. We're not going into all the aspects of the commissioning process. We're keying on a few very important aspects. There's an assumption that people are familiar with building systems commissioning, but if not, we have some highlighted resources as we go through. We'll talk about the state of the data center industry right now, about QC and commissioning coordination, evidence-based milestones, and then we'll talk about operational readiness in action, which is the impetus of our talk today. So there is a rising and increased amount of activity that we all know about. We see it on the news all the time. The number of data centers is immense, near 12,000 being developed worldwide. There's 6,000 data centers in the United States. That's actually going to double. $1 billion is a common cost now for a large data center. One I'm associated with is going in for $2 billion. And the escalation of the size is important to understand in our industry. It wasn't long ago, Alex, when a 10 megawatt data center was a big data center. And in a short period of time, 100 megawatts is common. And we're even looking at cooling and power density capacities that will get us to 1,000 megawatts in a similar footprint to what 100 megawatts does today. So both the technology, the investment in resources, as well as the changes in technology. I'll give you another example. Power utilization efficiency in data centers just 10 years ago was 2.0. That's the amount of power you need to do the work in the data center that you have to accomplish. We're now operating and commissioning data centers with a PUE of 1.5, but current design standards see that as really high still, and new data centers are putting on the board at 1.3 PUE. And that's important to keep in mind because 1 penny per kilowatt hour in a data center is worth about $1 million to data center operators.
And just to add to that, Jim, the rise of the data centers we're seeing not just in the United States or Europe, it's all over the world,
Yeah,
Africa, Middle East, Southeast Asia. So it's booming. The industry is booming and it will continue to boom.
it's right. And what's great about it too is it's American technology that's leading a lot of this development. The next talk about is the delivery models that I think are really important to understand. Demand growth and hyperscaling is where the industry is at right now. Obviously, there's a lot of work in data centers that are built into buildings and smaller scale data centers, but a lot of the concentration of the industry is on these larger build outs that are occurring. There's a lot of challenges right now, skilled labor being one of them. After COVID and moving forward, it's been much more difficult to acquire a lot of skilled labor in a data center commissioning market. You see a lot of different diverse people from all over the world that come into this industry and work in the United States to help us build out our building, and they learn it as well. Cooling complexity is related back to what I was talking about the power use efficiency, is the fact that how we cool the heat load that comes out of data centers has a huge effect on the sustainability, the cost of operating, and so forth. And there's just constantly evolution where we're now doing direct to chip using cold plates to cool it. And really, eventually, the technology wants to move over to where we do the direct to chip. And that's where we get from the 100 megawatt to the 1,000 megawatt. So it's continually going on. Technology completely evolving as we move along the line, and then the supply chain and the demand is very difficult. The other thing about the supply chain is in data centers, a lot of the owner furnished equipment is used, where we'll have owner furnished contractor installed versus contractor furnished contractor installed. And as a commissioning provider and asset tracking, which we need to do through our software and commissioning, that's all supply chain issues. And then the other thing is failures during the commissioning sequence are really not really tolerable. You know, we have to get to where we want to go in a way that gives us a critical path series of gates, milestones, so that things that impact the schedule early are mitigated so we don't end up at the end. And this again is where the means and methods that we're talking about comes into play. And then what makes a data center difference? Of course, they're complex. I mean, that's a given, right? Stringent performance in data centers is different than HVAC in a typical commercial building because the concentration of equipment and cooling and lighting is focused on an IT load and not on a human load. Because of that, our low temperature might be 32 degrees in a certain space, but we have to maintain that 32 degrees, 87, 36 hours of operation. In other words, 24/7, 52 weeks a year. And so the complexity is also in uptime and keeping things running. Of course, money is what drives every business. And in data centers, when you're talking about billions of dollars, tight schedule, rapid deployment of resources, and getting things built out with minimal delay is very, very important because of just the cost overruns and the also downtime that would be experienced by the network that needs to see these data centers come up. In other words, there's really high stakes at play to get these things online. and to do it. And there's a huge competition right now for data center space as well. So validated operational readiness at the completion of the quality control commissioning process is the most important thing that we need in order to be successful in building and commissioning data centers. And then we have the methods, which are the procedures and the commissioning process. Most of the people on EMA are familiar with the ACG Building Systems Commissioning Guideline. We're now at 2 volumes. It is basically a practical explanation of the standard 202 and standard 230 commissioning processes for new buildings and systems and existing buildings and systems. I recommend people who want to go into the commissioning process and try to understand it to start with the Commissioning Stakeholders Guide, which was put together by all the stakeholders in the industry using NIBS as an intermediary. And we advise that because it tells you all the roles, responsibility, explains the process. And then once you see the process that's involved with 202 and 230, I would also invite you to go to Technical Committee 9.9 at ASHRAE, which is the standing committee for guidance and mission critical facilities. There's a lot of good information there I can show you on the next slide. These are the body of work that goes along with standard 202 and standard 230. These are the guidelines. There's guideline 0 for the commissioning process for new, 0.2 for existing buildings. And then there are guidelines for O&M manuals, VRF systems, how to do technical requirements for HVAC systems specifically. And you see down there at the bottom right, that's the strategic guide I was talking about. And then there's also definitions that ASHRAE puts out. One of the things that ACG, ASHRAE, a lot of stakeholders in the industry want is consistent terminology, consistent process. So then we can do things like applying the means that Alex and I are talking about today to that established process. So the process is the framework, the skeleton, and then we build our jobs around that process based on what's really there, using a common language that everybody can really understand. And then here's the data center resource page. There is a $24 a year subscription to actually get into the data resources, but the bottom line is you get all the old data center guideline books, which was something like 40 books that are all put on this site now. The committee scope is concerned with all mission critical facilities, data center, technology space. And we've tried to align the data center commissioning guideline, the 1.6 that ASHRAE is probably going to publish this year, around the TC 9.9 development, and of course around the ASHRAE commissioning process, which is the same as ACG's. The takeaway here is that there are a lot of tools for you to use, and that commissioning, although it's really testing, it's also, you know, a turnover for beneficial use process. And these tools and this commonality helps us to communicate and effectively implement the policies.
So, Jim, thank you for going all over these references. There's obviously tons of different materials that are available. Now let's jump into operational readiness. As Jim has mentioned, operational readiness is going to be defined in the commissioning guideline for the data centers 1.6. And the operational readiness actually comes from airports. If you're familiar, airports have this specific process called ORAT, Operational Readiness, Activation, and Transition. And it really defines what ready means for day one. So the definition for operational readiness of a data center is that operational readiness of a data center is the demonstrated capability to safely, securely, and reliably support live IT workloads from day one through validated facilities, systems, people, and operational processes. And you can see how this definition can apply pretty much to any mission critical facility. The only difference is what it is that the building needs to be ready for. So obviously at the data center, it's a live IT workloads. Now there's a lot of important words in this definition. One of them is the demonstrated capability. It is very important to be able to demonstrate at every step of the operation readiness process, and we're going to go over every step later, but that capability needs to be demonstrated and available to every project participant. It is also important to understand that there are three major pillars for operational readiness. Systems, which are facilities, equipment that makes the building work. Data, and data is everything. Data is information on assets. Data are the O&M manuals, startup documentation, warranty documentation. So everything that is assembled during the construction process and needs to be turned over to the building owner. And obviously the third component, which is also very important, are people. So these are the people that will be accepting the facility and will need to be ready to operate and maintain it sustainably throughout its life. So there are some major principles of operational readiness. Well, first of all, it's not something that can one party deliver, right? Just by itself. It only really works when every stakeholder buys into the definition of what ready really means. And that's starting from the owner, to general contractor, to trades, to the commissioning provider. And it's important to understand that the roadmaps only work if there is a commitment. Without a commitment of every stakeholder, then the roadmap is just a presentation. It just slides. It's not a real process. And that's also what's important is transparency, because transparency really eliminates the false ready signal that typically cause projects to sleep. And transparency replaces debate or somebody's opinion with real data, right? Because if prerequisites aren't complete, then we need visibility into this really early. If documentation is missing, we need to know that documentation is not available before we can start testing. And then if readiness is assumed instead of being proven, it will be exposed in the field. Transparent reporting of readiness is what turns commissioning into validation instead of discovery. We've all been on projects where you start discovering issues during functional testing. And what that really means is that there is a failure in quality control. We're going to be talking about how quality control and commissioning need to work together. But again, it's very important that commissioning needs to become a validation and not a discovery, right?
Alex, when that failure occurs, it's usually about accountability, right? And we set up a process that serves the vendors, that serves the installers, that serves the owner, so that we're not competing with each other. We're seeing everybody's progress at the same time in real time and being accountable for who does what. And when it falls behind, you're accountable for that.
Exactly right, Jim. Commissioning doesn't make projects ready. Commissioning confirms whether readiness has been achieved through execution or not. And operation readiness, if you think about this, it's really a mindset shift from schedule-driven declaration of to evidence-driven conformance.
Yeah.
Let's talk about responsibilities and accountabilities. So, operational readiness breaks when it is really not clear who is accountable for what. And it's not about blame, but it's about clarity. So, as I mentioned earlier, commissioning validates outcomes, but readiness is delivered through execution. If quality control is not complete, again, commissioning becomes a discovery. And that's when the projects fail and when the projects don't meet schedules. There are 6 major players that I'm showing on this slide. We have the owner who sets expectation and accepts readiness. There's engineer who defines readiness. There's trades that delivers proof of readiness. Vendors that support readiness, GCs deliver readiness, and then commissioning provider validates readiness. But if we go deep into this, what are they really responsible and accountable for? So the owner defines owner project requirements, actually provides the funding for the readiness, and accepts the risk at the turnover. The architect and engineer define the design intent and make sure that it aligns with the owner project requirements. And then general contractor drives execution and enforces quality control completion prior to the start of commissioning testing activities. And then the trades provide documented proof of installation and startup. Vendors provide factory startup documentation. And at the end, commissioning provider validates compliance with owner project requirements, validates systems performance, and identifies gaps. But it is very important to understand, while they do identify gaps, they're not the ones that close them, right? There's a team.
Also, Alex, we look at this as not being in silos, right? We want our process to open up communications, have clear communication protocols, and get these different stakeholders working together instead of just stuck in their own individual environments.
Absolutely, absolutely. And that's what I was talking about, operational readiness being a mindset.
Yes.
There are 5 levels of commissioning, and these are the main levels of commissioning. Guideline 1.6 is going to define what those levels are. I say main levels is because there are actually 6 levels, 0 to 6, and we're going to go over them in detail. But at this point, I just want to bring up, because we're going to be talking about the gating process and the milestones. So the 5 major levels are level 1, which is the factory testing, whether it's a factory acceptance or factory witness testing. Level 2, which is the installation quality control checks. Level 3, these are your energization, startup, and pre-functional tests. Level 4 is functional testing, and level 5, integrated system testing.
And really, these are just the backbone levels that we customize those for each job, Alex, right?
Yeah, absolutely, absolutely. And again, we're going to go over those levels in detail a little bit further. So let's talk about the operational readiness roadmap. It is very important to understand that it is not a schedule. It's not a typical schedule that you would put in a schedule tool. It is a sequence of verified conditions. And that's when we talk about those gates. Operational readiness doesn't happen just at the end of the project. It is built through controlled gates from day one. And there are multiple gates that exist throughout the operational readiness process. There's a design readiness gate, and that gate makes sure that the owner project requirements are defined, the related to data centers, redundancy intent is clear, and acceptance criteria is defined. Now, why is that important? Well, if the acceptance criteria is not defined, then how are you going to measure the readiness at the end of the project? The next gate would be the installation readiness gate, and it's typically related to completion of the quality control activities. So that gate requires completion of installation of equipment per design documents, things like torque logs complete, tags removed, the vendor startup documentation is in place, and pre-functional checklists are completed.
To elaborate just a little, there is torque verification that you mentioned, and then they mark the terminations in data center equipment, particularly the IT equipment, but low voltage and high voltage, all that tamper sealing mark. And then we use tamper seals or locked doors Once things are ready for a pre-energization inspection, then you move over to tamper sealing and door locking. So you're marking and you're validating and then you're documenting. So the gates are more than just a word. They have real physical applications like torque marks and tamper seals.
That's exactly right. And in addition to that, a validation conformance, right? You
Mhm.
have a support and documentation for that. And
Right.
that's when you put together your commissioning plan. This is where you're going to define what each gate means. Next
That's
gate
right.
after that would be the functional testing, right? That's where
Right.
all the controls are verified, interlocks are confirmed, and then all the evidence from all the tests have been uploaded into a software, and it's traceable and verifiable. The next gate would be integrated system testing. This is where you do testing, across multiple systems. You validate different failure scenarios, and then put together your recovery path documentation. And then also you have to make sure that the operations team are present and engaged, right? And then
Mhm.
the final gate would be the transitional, right? Operational transition. So this is where you need to ensure that every single operation process is validated, your standard operating procedure, method of procedures, emergency operating procedures. You want to make sure it's all approved. You need to make sure that all the training has been completed and supporting documentation is available. All the documentation is delivered, and so the owner acceptance criteria is satisfied. So as you can see, this all connects, every activity back to the owner project requirements. Now, the failure on most projects, right, in terms of the schedule, don't happen because of bad testing, but because the gates are assumed to be closed, but never verified. So what gates really do is to remove opinion and to replace debates with data. What we say is you remove your feelings from determining whether a particular activity has been completed or not, and you just rely on facts. You rely on evidence, and it's important to understand that you do not arrive at readiness. At readiness, you really prove it gate by gate. We talk about quality control and commissioning, and this is a very important to understand. Quality control and commissioning really go hand in hand. We're going to be talking about the levels again a little bit later. You'll see there is a section of operational readiness that specifically talks about the quality control activities. And it is important to understand that, and I mentioned this before, but I'll mention it again. Quality control is really where you confirm that the equipment and systems perform per design documents, right? You ensure that everything has been tested, everything has been installed per design documents, per owner project requirements. And commissioning is not a troubleshooting event. It validates successful execution of quality control activities. If and when you discover issues during commissioning activities, that means that there was a failure during quality control activity. It is
You know,
important
we
that contractors stay engaged throughout the testing process. Go ahead, Jim.
I'm going to say that, this is where the silos are most dominant a lot of times on projects, where quality control is in one column and commissioning is getting information secondhand. And this concept of integrating quality control and commissioning, put them on common platforms, common meetings, common communication, share vendor information. It's the total only way you're going to get operational readiness accomplished in a timely manner. We can't work in a bubble anymore. With the size of projects, the numbers of assets, We have to let quality control do their job. They have to let commissioning do our job. We just have to know what each other's doing at all times. I mean, it comes down to simple things like missing screws on panels and things. And we just have to be able to work together. I mean, do I want to write up 500 items for screws when we could just communicate through the quality control issue resolution and get it accomplished? So there's no way to get to op readiness without quality control and commissioning integration.
Yeah, you're absolutely right. Let's talk about what ready means in the field. And this goes back to the discussion about handoff between the quality control and commissioning, right? So these are just some component ready examples like controls are live or alarms are verified. But it is also very important to understand that being component ready is not necessarily the same as system ready, because readiness only counts when systems work together. I'll give you an example of a system not being ready. So a generator passes factory testing and then goes through successful startup process. But during IST, we simulate a utility outage, and then the generator starts perfectly, but the ATS logic didn't transfer the load, and that didn't happen because the interlock was not programmed. So what's the result? Well, a ready generator, a component ready generator, didn't actually support the mission critical operation. So it is really important to understand and make sure that the entire team, that every stakeholder understand what ready means at every step.
And Alex, it starts early, right? You begin with uh, factory testing, as you mentioned early, right? This will be in the OPR, which is so important in data center commissioning. But you begin with factory testing, where you find any kind of factory errors, and we still get loose wires, non-terminated grounds, and stuff. But we have to have the factory testing. Then on site, we do receiving checklists. We do set in place inspections. We do installation and documentation verification. We do clean walk, torque verification, like you mentioned earlier, and then all the pre-energization inspections, and then the tamper sealing or securing of the spaces. And then finally, we get to energization and startup. So it's not by accident, what Alex is talking about with these gates. And where all that happens is in the OPR, because the owners, particularly on these hyperscale projects, they know what they want. They're actually even including their own commissioning specifications and their own integration of QC and commissioning in their procurement processes. And they understand the importance of what a good OPR amounts to, which is basically defines the owner's intent for the system. It's not necessarily a technical document, it's just an explanation of what's required. In a data center context, it talks about redundancy, maintainability and sustainability of equipment, cycle life, what the operational workflows are, the performance requirements. We also deal with a lot of metrics, Alex. Like I mentioned earlier, the PUE, there's ECM, there's just a ton of different electrical and mechanical efficiency marks. And everything has to be based on the owner's requirements, which usually are 8736, 24/7. And the criteria for turnover has to be explained clearly, like Alex was talking about. Every torque mark has an associated checklist and series of inspections that goes with it. Every gate has a set of criteria that must be accomplished, and all this has to be laid out properly in the owner's project requirements. It has to be able to tell you what you need to do on the job. The next aspect that we're going to focus is the pre-construction alignment. And this is important just in the sense of communication, getting all the stakeholders on board. This is where roadmap is important. Everybody needs to clearly understand the process, and everybody confirms from an early point, early on, what their roles and the responsibilities are. What are the handoffs between trades and vendors? And here again, we're into owner furnished equipment versus contractor furnished equipment, vendor installed versus contractor installed. So chain of custody and responsibilities have to be clearly defined, and what is the handover from one entity to the other. The testing expectations have to be aligned too in order to set up our readiness gates. So once we have things installed, it's just not a matter of putting everything in place and turning the switch and hoping nothing catches on fire. It's really important that everybody is aligned with the steps on the way. If you're starting up a generator, for example, it starts with tank inspections and you move all the way through the process. So it's important. And the prerequisites are clearly defined. And this is where the roadmap sort of breaks out a little better than a typical Gantt schedule, where you can, in a very symbolic or pictorial way, see what that whole process is instead of just a bunch of lines on the schedule. Schedule is important, but the roadmap is very helpful. And then what we want on this are the milestones, like equipment and systems when they're installed. I read through you the set in place inspections and all the things that need to be done. And then the controls and the point-to-point performance, preliminary functional testing, and then functional testing, and then finally the IST, the integrated systems testing. So that's a lot, Alex. It comes out of the OPR, but it's about communicating these things together. Pre-functional testing comes down to what Alex was trying to say early, that we don't just get the commissioning and hope everything works. We actually get them installed, go through all the gates, and one of the gates is the vendor or contractor or installer does these functional performance tests before the big functional performance test comes together, so they know they're going to pass beforehand. So you do QC is complete, then you move into the component and safety and readiness checks, and you make sure everything is ready. This can be pre-energization, exercising switches and things on electrical equipment, so you don't break a disconnect handle as part of your commissioning test. You break it on your pre-commissioning or your pre-functional testing. So that finally gets us to functional performance testing of all the individual components and then integrating those together. So really, all modes of operation have to be covered in data centers. That may be sometimes simpler than in a school because there are less modes, but the failure modes, the redundancy things, that's where the complexity comes in on a data center. So we have to be able to test for all normal operation, what happens if the system is disturbed, and then what is the recovery of the system when that occurs. And in a data center, there really is no time for recovery. So we have redundant equipment that might kick on, emergency generators that take over when grid power is lost, and so forth. So all this integrated system testing, a lot of times it includes, or really should, a total blackout test where you have two redundant feeds on the building and you completely fail one feed, see how it recovers, and then you fail the other feed, you total fail all power. So an integrated systems test in a data center is a lot more complicated, and it's also power intense. So if I'm setting up a 10 megawatt power plant data center, I'm going to need 20 megawatt from the power sources in order to do the 100% redundant testing. So that's some of the things to think about, and that's why, again, this roadmap is so important. And I like, Alex, how you incremented this more discreetly than what the basic ASHRAE levels are.
Yes. So in this diagram, I'm showing six levels, 0 through 6, I should say. And the reason I'm showing 0 through 6 is because they all are very important, right? Obviously, as we know, commissioning starts with owner project requirements and and the base of design and the design intent, and that's what level 0 is. And so this roadmap shows you a clear path through every step of validating the performance and readiness at every step. And we talked about, already mentioned milestones. We mentioned gating, and basically this workflow shows you there is a gate at every step for going from level 0 to level 1, which is the factory testing, bench testing. Then completion of those activities signifies pre-construction completion, right? And then we go into the quality control phase, right? That is level 2. Sometimes level 2 is broken by level 2A and 2B activities, which are, level 2A would be activities related to installation of equipment, and level 2B will be related to quality control activities. We talked about gating, And in data centers, the completion of a gating is related to a tagging. A tagging, it basically a physical tag that is typically attached to a piece of equipment, and it designates the state of the equipment at each at the present time, right? So, for example, at completion of 2A, the equipment will have a red tag, and that again designates that the equipment has completed a certain stage, right, a certain level, and now the gate is open to move to the next level.
And
Now,
then, Alex, we document all this in the asset management software also. It's not just
that's
on the physical equipment.
Yeah, that's correct. And it's important that as you go through through these levels, the definition of each level is pretty standard across different data centers, whether they're co-locators or hyperscalers, while tagging the tagging is common, but the coloring of tagging is not necessarily the same. So it is most often, these are these are the colors used, but they're not necessarily, the same across all the data centers. So level 3 activities, these are related to pre-energization, the startup, verifications, and then also pre-functional testing. Sometimes they're broken into level 3A and 3B. Sometimes they're not. Sometimes there's just level 3. And completion of level 3, there is a tag, green tag typically, and that designates mechanical completion of testing. And then level 4 and level 5, we talked about functional testing and integrated system testing. Again, these are designated with gates related to tagging, blue tagging, and white tagging. And then the last one, but is also very important, is level 6, and this is the handover to building operations.
No tag.
No tag. Um, Let's talk about how software can help. Obviously, these days you're probably not going to be engaged in a commissioning project, especially in the commissioning of a data center project, without relying on a commissioning software. And your commissioning software, what it helps you, especially on a data center project, it helps you track every step of operational readiness. It helps you track the milestone. It helps you track the gating. It helps you track all the documentation and evidence of completion of certain levels, right?
Just accounting for all the assets, Alex, is huge.
Absolutely, because the day one is not when you are getting ready to start operating the facility and having your CMMS ready or DCIM system ready. Day one means that really everything is ready for operation. It means that if there's a work order, if there's a ticket that needs to be addressed, it needs to be documented in the system. And again, the commissioning software can provide you with all the tools that you can use in order to track operational readiness at every level. We talked about milestones a lot. And, we all used to milestones, right? In construction, there's always milestones. Maybe it's 50% complete, substantial completion, ready for commissioning. But in operational readiness language, a milestone is a readiness gate that must be proven before moving forward. So if prerequisite conditions are not met, the project should not be advancing. And even if the calendar says that there is a next step for it, and there is various evidence that can be used to achieve a particular milestone to open a gate. So this is just some examples of the evidence. It could be signed checklists, startup reports, inspection results, control point-to-point verification, documentation, validated sequence documentation, and the strong evidence reduces risk for not successfully completing functional testing and integrated system testing. And it is, important to understand that one of the most important failure points to see on the project is when, a team declares that they're ready for AST just because the date arrives, but the site is really not ready. So when the testing starts, then you discover that the prerequisites are not actually met. The sequence were not validated in normal mode. Documentation is not complete. Interlocks are not, proven. And basically, at that moment, the integrated system testing basically turns into the troubleshooting. And that is not a testing failure, by the way. What it is a failure of is a failure of readiness.
Mhm.
The last part of readiness, and that is the level 6, is the controlled transition to operations, right? There are multiple steps that are, required as part of the successful handover. One of them is training. Obviously, the operators need to be trained. They need to obviously understand why equipment is there, what it does, how it's supposed to operate, and not only in your standard operating process, but at every other operating process as well. Emergency operating procedures, method of procedures, they have to be trained in all of that. Again, they need to have all the supporting documentation. They cannot be taking control of facility and being ready to operate it on day one if they do not have all the required documentation, right? And obviously, the most important part is the facilities, the equipment and equipment, right? You have to have all the documentation, all the evidence that every equipment and system have been tested successfully. And basically, we're at our last slide. The key takeaways. So what I'd like you to get from this presentation is that operational readiness is not something that you declare at the end of the project, right? It is a process that you prove step by step. So when milestones are evidence-based, day one becomes really predictable. Jim, anything to add here?
No, I think you've summed it up pretty well, actually. It's a situation where, you want a process in place that's intentionally redundant, goes a long time, covers all aspects of the project, and uh, you can't overestimate how much time and energy is taken to accomplishing these things. And that's why the technology tools are so important to getting us there, both for communication and documentation. So I
Perfect.
appreciate
Well,
it,
thank
Alex.
you.
That's
Yeah,
pretty
absolutely.
good summary.
Well, thanks again, guys, and happy to take any questions.
All right, thank you both for that discussion. We've got a couple questions coming into the Q&A. Just a reminder to everybody listening, you can drop your questions in the Q&A at any point, and we will try to answer as many as possible. The first one says, what is the outlook of SMR design for cooling of data centers? Also, is ASHRAE going to issue guidelines for commissioning of SMRs in the future?
I think SMRs are in the future. I know there's a lot of talk about them, but I have not seen one successfully permitted. We've done a lot of conversation with Idaho National Labs and the DOE about this through the 7x24 group. And, it's really going to potentially be, we know how to do SMRs. We have lots of, vessels and different things that operate on them. But the only two operating that I'm aware of at the moment are one in Antarctica and one in China. I think near term, it's going to be natural gas turbines. And then I think using already built out power plants, converting them to natural gas or converting old mothballed nuclear plants and getting them up. And I've got a list in my workbook of 17 nuclear power plants that have been permitted for production to go online by 2030. And the SMRs will come in, but the technology and particularly the regulatory side of it has to really advance before they'll be able to do that.
All right, next up, would the OPR for data center commissioning be significantly different from that for hospitals?
Yeah, it would be. And in fact, hospitals themselves are significantly different in terms of commissioning plans because they too have, all their special criteria. So in a hospital, a lot of times you're worrying about infectious disease control. In a data center, you're worried about uptime. The manner in which procurement occurs in a data center, how you sort out the chain of custody between vendor supplied equipment, the means by which you test utilizing the vendor and having the vendor interact with your asset management software. These are items that are procured through the owner to allow the vendors and the contractors and everybody to participate in quality control on a common platform. I think the dissolving of the silos between quality control and commissioning is the most important thing going on in data center commissioning right now, that we need to find a way to get these things in common communication, common platforms, and work together. And I think those are some of the big differences. Also, the scale. For example, a data center you might work on now has 42 300-ton chillers on it. I mean, for a lot of people, that's 20 to 30 projects to commission 42 chillers. But the scale and the manpower required is also, it takes a lot to put in the commissioning plan to sequence all this correctly. Alex, you got stuff to add.
Yeah, it's important to add that that is one of the reasons data centers are getting their own guideline, right, Jim? I
Hmm.
mean, because they are different. So ASHRAE is going to be publishing additional guidelines in the future for different types of facilities, but they specifically started with the data center because there is so many differences in how accomplish successful readiness of that
One of the
type of
big things
facility.
in one of the big issues in data centers is the third-party integrators. There's just so much equipment that comes in on skids or in containers that has been factory tested and receives a minimal amount of site testing, but you nonetheless have to integrate how factory testing occurs on site, who documents that, and when it gets put into place. And then in the guideline, there's just so many things that are nice to have on standard commissioning, but we have to have them. Factory testing, factory witness, factory acceptance, receiving checklists, set in place inspections, I&D, the things I talked about earlier, multiple clean walks, and then the setting of set points as well as the things until you energize and test. So there's quite a bit of difference with a data center.
Right. And also again, the levels and the and tagging. So
Yeah.
while you can apply the same principles to any type of facility, but with data centers, it's a very clear differentiation of how you move from one level to another using the tagging process.
I also think that when we publish the 1.6, Alex, it's going to look a lot like the new enhanced commissioning. It'll be applied to other areas, not just data centers.
Absolutely.
All right, next question says, what steps of learning do you recommend for someone who wants to work in data center commissioning?
Boy, the first thing I would say is to look at 7 by 24, which is a association for data center operators, and look at the programs and the training that they offer, and look at how you can leverage your skill set against the training you need to work in a data center. There's a lot of levels. There's operator, there's designer, there's quality control, there's commissioning, and all those levels are discussed on 7 by 24. That's a good one. The other thing is what I mentioned in the presentation. Take a look at TC 9.9, and it very clearly lays out all the criteria for commissioning. In the data center encyclopedia, it's in the miscellaneous category on the folders. But then you can also look at all the detailed information about data center design and operation themselves. It's on TC 9.9. And then it's just a continuous learning process because the technology changes from day to day as we move forward, and that's the exciting aspect of it.
And there are a lot of industry conferences related to data centers. So I would really recommend attending some of them that they really speak to specifically to data centers.
You can also look up data center names on the internet And most of the big data center developers, the wholesalers, the hyperscalers, the colos, they're all blogging and promoting their services and their processes. So that's also just look up if maybe Google the five biggest data center developers and then look into their blogs. You'll learn a lot that way too.
All right, I think we've got time for one more question. So this one says, would you say that the cooperation between the commissioning authority and the general contractor or contractors works better with data center commissioning, or is it about the same?
It's no comparison. The cooperation simply because the people operating in the data center world are building data centers as their main line of work, and everybody is on the same team achieving the same priorities. And so I find a great deal of difference between dealing with, Mitsubishi, who's providing UPSs, or Cat Generator, who's providing generators. And, these companies are providing hundreds and thousands of pieces of this equipment to these data center operators, and they consequently have a large stake in servicing and supporting the build outs. And because of that, and because of the specialty contractors that are involved nationally, you just have a more coherent process. That's not to say that it's great because the wheels can come off of anything, but I do find it's just the stakes are higher. Everything is more critical in a data center environment. And because of that, I've seen less stress actually as a commissioning provider in terms of being able to communicate and integrate. Stress comes from other places like deadlines, but really, Alex, I've found really good success communicating with contractors and having common relationship. And it's about relationship. Everything we do, Alex, you and me, the software that we use and the people that use it is all in relationship.
And I think that the reason it's a little bit different is because it starts with the owner. I think in a data center world,
Yeah.
owners typically,
Mhm.
um, typically, I'm not saying all the time, but typically are more engaged from day one. They know exactly what they want. They know exactly how they want their facilities to function. They set the culture, they set the expectations for every step, those levels, gating, tagging. Typically, it's all outlined. Typically, data centers will have their what they call commissioning playbooks that outline what each step requires, who is responsible for what. So I think because it starts with the owners, it typically sets the right mood, the right tone on a project, and leads to better outcomes.
I think that's a great answer, Alex. I couldn't agree with that more. Just in a minute left, would you tell everybody about ORAT and operational readiness and how this evolved?
Yeah, so as I mentioned a little bit earlier, Operation Readiness started, well, actually, I think it came from the oil industry, but it was very broadly adopted in airports. ORAT, Operational Readiness Activation and Transition. This is a process that every airport goes through, and it really tracks the four components, right? The people, the assets, documentation, and the process. Okay, and again, the thinking, the idea behind operational readiness, the process of operational readiness, can be applied to pretty much any mission critical facility, especially to data center where those steps are so critical.
So I guess that wraps it up, huh, Cassie? Thank you, everybody.
Yes, thank you so much for everybody attending today. Thank you both, Alex and James, for a great presentation and discussion, and to Facility Grid for sponsoring today's webinar. Thank you all for attending. Before we wrap up, we want to encourage everyone to join us for CX Energy 2026, which will be happening April 21st to 24th, 2026 in Chicago. You can check out the full technical program and register today at cxenergy.com. And in conjunction with CX Energy, EMA will be hosting the EMP seminar and exam, which is a great opportunity to learn more about energy management and prepare for EMP certification. You can register for that at energymgmt.org. We hope that you will all join us, and thank you for participating today. We'll see you at the next webinar.